In this short video, I'll introduce hydrates with an example calculation of 2. So a hydrate is just an ionic compound that contains water, and typically we'll want to quantify the water because the water typically, when you take the hydrate and dissolve it in water, you lose that water to the solvent, and you therefore need to accommodate it in the dry mass of the hydrate to begin with. Okay, so typically the general chemistry is an anhydrate plus n lots of water can give a hydrate. And these can be ionic compounds. Well, these are ionic compounds. And you can go back again. So the hydrate can be decomposed into n lots of water plus the anhydrate. So let's say this is A, and we have n lots of B. Then we could produce A, and it's usually written with a dot and then the quantity of B. So you see this dot used for hydrates. Okay, so that's essentially what a hydrate is. Let's see a typical example of a calculation where you're asked about a hydrate. Okay, so we're told that a hydrate of magnesium sulfate has a mass of 13.52 grams. Okay, and we're told that the sample is heated. The sample is heated until no water remains. How do you know no water remains? Typically in the lab you would heat, you would weigh it, and if any water remained, upon a second and a third heating, the mass would decrease. So you typically heat it, weigh it, heat it again, weigh it, heat it again, weigh it, and you repeat that till it's a fixed mass, and then you know there's no further water to be lost. So let's say we've achieved that. We're told that the anhydrate, which we believe is now a true anhydrate, the anhydrate has a mass of 6.6 grams. And we're asked to find the formula of the hydrate. Find the chemical formula of the hydrate. Okay, so let's do the answer in red. Okay, so very similar to the empirical formula type calculations in another video, we need to calculate moles and look at mole ratios, and to get moles we start with grams. So the first thing we can do is calculate the mass of water lost. So the mass of water that's lost, that was originally in the hydrate, is equal to the original hydrate sample mass, which is given in the question, 13.52 gram. All right, let me bring the question into view a bit more. So the mass of the hydrate minus the mass of the anhydrate. Okay, so the hydrate minus the anhydrate. We're subtracting, so we propagate least decimals. So we're good for 2 decimals, but we don't want to round prematurely. So we put dash and then we have extra zeros. Okay, so that's the mass of water in gram. We can now convert all the masses to moles. So first up we have the anhydrate, which is the MgSO4, if that wasn't obvious. So we have 6.60 grams of MgSO4, and we know that by definition 1 mole of MgSO4 is the weight in grams. So we've got a magnesium weight, we've got a sulfur weight, and 4 oxygen weights or masses, and that's equal, when we sum them all up, to 120.36 grams of MgSO4. Gram cancels gram over here, and we're left with just moles. We're multiplying now, so we're good to sig figs. We're good to 3 sig figs because of our input over here. 6.60 is 3 sig figs. So that gives us 0.0548. Here's where my insignificant line comes in. 35 mole of MgSO4. Okay, so that's my moles of hydrate. Now I need to do the same for my moles of water. So the water, I've got 6.92, okay, so 6.92 grams of water. That was from my previous calculation. And I know that 1 mole of water is equal to 18.02 grams of water. Units cancel. I'm good to 3 sig figs again. So this is 0.38401 moles of water. And just as with the empirical formula type calculations in another video, so I'll go on to the next page, we'll just look at the mole ratio. So what this tells me so far is I have MgSO4 to water. Why black? Why not red again? I have a MgSO4 to water ratio of, if I can find my number, okay, so I just lost my number, 0.054835 to, and the water number was 0.38401. Okay. Divide both sides by the smallest number. So let's use blue for that, I guess. So 0.05485, 0.05485, that becomes 1. This becomes 7. Remember, we need whole number integers. So this implies MgSO4, there's that dot, 7 H2O. So that's our hydrate. It's got that characteristic dot that you see, that dot that we alluded to earlier on. Okay, have we answered the question? Find the chemical formula. Yes, we have found the chemical formula. So for my students, I'll post a worksheet with a gajillion examples of this, but essentially they're just replications of this question with different numbers. So that is hydrates.